Well, now we come to grouping. Now, grouping is where you take a bunch of records and visually you combine them into one line or into a combination of lines, but it's almost like squashing a bunch of records into a smaller package visually, one line on the screen, and it's a way of basically combining the data to give an overall summation sort of view. Well, it's best to try and represent this visually. So in this example, we've got a simple table with 3 records and a column description, and it's got 3 values there, all the same, A. Now, if we were to group that by description, we would effectively collapse or squash, if you like, those 3 rows into one row where that description value was common. And as you can see here, this visually expresses what's happened. We've got our one common value of A in description, and a group by description, we basically take each unique value and display it on its own single row. Now, if we had more than one unique value in description, like so, and we were to again group on description, then we would have 2 rows because there are 2 unique values of description. And to represent that visually, you can see that one collapsed row behind the scenes is represented by 2 physical rows there, and that grouped row there, which is represented behind the scenes by 1 physical row there. Now, where the real power of grouping comes in is within those grouped rows, we can perform calculations on the physical rows that are represented within that row. You can perform calculations on a range of the values within that row, for example, totals or averages or minimums and maximums. So coming back to this example, supposing our table has 3 rows, description or just one description value of A on all 3 rows, but it has an amount column, and that amount column has some integer values. What could we do if we wanted to group them by description, but what could we do with that grouped amount column? Well, what we could do, for example, is we could total it. So on our grouped representation, we can come up with an expression where we apply a grouped calculation against the amount, grouping within that calculation based on A. So in this case, we've got the total amount, and that is the total amount of amounts pertaining to description A, and that's there, 57, which is the sum of 10, 15, and 32. Well, let's just get straight into it. So I'm going to start a new query, and I'm going to select everything from sales order detail. Okay, so we've got a whole bunch of columns here. There's the prime key, sales order detail ID. There's the quantity of the sale, the product that we're selling, the price, the line total. So just to, before I go on my next step where we start grouping, I'm just going to put a where clause in here. So look, I've just added a where clause where I've selected only the records where modified date was in the year 2011. Now, I've done that for a reason, but let's get straight into grouping. Now, let's say I want a snapshot of all the product IDs in this table. I mean, obviously I can see we've got a 777 there and a 745. There may be many 777s, there may be many 745s. You know what, let's just order it first and get a rough idea of what values are there. Okay, we've got some 707s, we've got some 715s, I think there was a 714 up there briefly. Well, that's great, but if I want a sort of a snapshot overview of what are the actual distinct actual values that are available within this set, how do I do it? Well, that's where grouping comes in. So I'll just get straight into grouping by product ID and have a discussion on it. What have I done? I have introduced a new clause. This is the group by clause. Now, in the scheme of things, the group by clause comes after the where and before the order by. So what does it actually do? Well, it's telling us by what criteria do we collapse these rows? What is the distinct value by which we arrange our rows? And we're saying it's product ID. Now, that effectively, in plain English, that is saying give me one row for every distinct value in product ID. So let's just do it. Okay, and there we go. Now, you probably noticed we had lots of 714s and lots of 715s, but we've only got one here. We've only got one row for each product ID because each one of those rows represents however many product IDs were within that grouping. That may represent 5 physical rows, that may represent 6 physical rows. It just depends. Now, to demonstrate the effect of grouping and the sort of things we can do with it, I'm going to start a second query window over here, and I'm going to tweak the query in it to be the same as this, but I'm going to ungroup it, and we're going to limit it to just this product ID here. Okay, so these are the 707s within this set. We've got the same other condition here about the where. So this is within this set of 707s where the year's 2011. These are the records that make it up. And if we scroll down here, there are 119 of them. Now, let's say we want to, in our grouped set, we want to find out what is the number of records within that grouping. How many physical records make it up? Well, there's a very easy function to do that, and we'll start a discussion about the functions you can use within grouping. So let's start the discussion about grouping functions. The first one I'm going to show you is the count function. Now, what the count function does is it returns the number of rows within a grouped row. So if a grouped line is represented by 10 physical rows, count can show you 10. But it has two usages. One is you can write count and pass it in a column name. And what that will do is it will pass in the number of rows within the grouped set where there are non-null values in that column, where there is an actual value in that column. If within that row, that column name has a null, that doesn't get counted. It doesn't increase the count, so to speak. Now, a far more easier representation that I like to use is the other form, which is count star. And that just counts all the rows within a particular grouped row. So let's get stuck into some demonstrations of both these forms. So here we saw that in our set of where we've got product ID 707, there are 119 rows, 119 707 product IDs subject to the condition about the date. So if we go back to our grouped set here, how do we find that out? Well, this is how we do it, using count. Okay, what have I written here? I've said count star. This is the second form of count, and that will tell me all the rows, regardless of columns or regardless of values of columns, just give me everything within that grouped row, and I've given it an expression column, as we do. So let's see what happens. And there we go. Now, coming to the 707, that's telling us 119, and that's exactly right, because as we saw in the ungrouped version, there are 119 rows. Now, I'm going to show you the other form of count where we actually pass in a column name. Now, to demonstrate this effectively, I have manipulated the data. You won't see this in your copy of AdventureWorks, but I've gone to one of these product ID 707 rows, and I've gone to carrier tracking number, and I've just set that to null. So how does that affect our usage of count? Well, if we go back to our grouped set here, I'm going to count based on carrier tracking ID, and let's just see what happens. Okay, so I've gone count, carrier tracking number as carrier count. Now, looking down here, you might be forgiven for thinking that that is going to return 119, same as this. But will it? Let's have a look. No, it doesn't. What does it return? 118. Why? Because what this is counting is all the instances of non-null values in carrier tracking number. It's nothing to do with the values itself. You could have values in here of, say, 1, 3, X, a million, doesn't matter, the values I mean. But what it is counting is where there is a value. So it counts these, it does not count those. So it can be a handy tool if you're interested in finding how many of these have null values, if you're seeking out null values within your set. Personally, I have never had a use for it myself. If I'm interested in null values, I will just simply do a non-grouped set seeking out where carrier count is null. So in all my 20 years, I really have never had to use this. Personally, I think it's a little bit confusing. I mean, you're counting that, but it's not counting where it's null. I mean, but in terms of counting non-null values, I just simply have never had a practical use for it. So, you know what, I definitely have a practical use for counting the sheer physical number of rows within that. That's I've always used that. I've never had a use for that. Personally, I would recommend just stick to using count star. So, you know, to clean this up a bit, let's get rid of our second count function there. Now, if we come back to the ungrouped set, I'll just get rid of that condition about limiting it to 707s and just leave the condition about 2011 there. Now, if we scroll down to the 709s, notice that there's actually several different instances of special offer ID in that set. Amongst the 709s, we've got several ones, we've got a 2, we've got a 3 there. So let's say that we're interested in our grouped set here. We're interested in getting at some of those special offer IDs inside there. We want to know what are some of the kind of values of special offer ID that we've been giving out to people who order product 709. Well, what's to stop us just simply selecting special offer ID up here and just see what happens. Okay, so I've selected it. I'm still grouping by product ID, but I've selected it, and let's see what happens. Oh dear, we've got an error. What is the error? Column special offer ID is invalid in the select list up here because it is not contained in either an aggregate function or the group by clause. So what does that mean in English? Well, let's just put things back the way they were. I'll just cut that and I'll redo the query. So what it's saying is that within, we are grouping by one factor here. We have got one row for the 709s, one row for the 708s, the 709s, the 710s. Now within that row of 709s, we've got maybe 4 different values for special offer ID. But if we select it, how do we represent it? Well, we really can't because we've got one row there for all the 709s. But the error is sort of SQL's way of saying, well, hang on, you want me to put in special offer ID, but within that set, there's like 3 different values of special offer ID. 1, 2, 4. Which one do you want me to show? I can't do it. So the error is sort of SQL's way of saying, well, hang on, I've only got one cell per row. I can't show many values within that cell. Well, what can we do? Well, what we can do is we can expand our grouping so that we're grouping not just by the product ID, one row for each product ID, but we can expand that and have multiple rows, and they can show, the multiple rows can show the individual values for our special offer IDs. So let's just give that a go. I'll show you what I mean. Okay, what's just happened? Now, instead of one row for 709, we've now got 4, and we're showing each of the unique values of the special offer ID. So that's telling us that within the 709s, there are some 4s, there are some 1s, there are some 3s, and there are some 2s. That is perfectly legitimate. So let's start compiling some grouping rules. And we've seen the first rule already, and that rule is we can only select a column in a grouped set if we are grouping by that column. Now, there actually is an OR on the end of that. There's another way that we can select a column, and we'll come to that now. Now I'll just tidy up my query a little bit, and I'll order by not just product ID, but I'll order by the special offer ID as well to sort of make it look a little bit neater. Okay, looking pretty good there. Now if we go to the ungrouped set, note that within our various sets of product ID we've got an order quantity, various values of order quantity. Bear in mind order quantity is an integer field. So let's, coming back to our grouped sets, let's say that we're interested in the order quantity. Now if we drop it into the select clause, I bet you can guess what's going to happen. We've got that error again. Column order quantity is invalid because it's not contained in either an aggregate function or the group by clause. Now I'm just going to undo that. And it's the same thing again, because within, for example, this row here of 709s and special offer ID number 2, we've got 8 rows. So this grouped row is represented by 8 physical rows. So if you want to know about order quantity ID, that error is again saying, well, hang on, within that order quantity ID there's various values, 1, 2, 3, 6. How do you want me to show it? How do you want me to represent what is many values within a grouped set that is 1 representing the entire many? How do we do that? Well, that comes to the second exception that we can get around that error, and that's using an aggregate function. So that brings us back to a discussion about grouping functions, because another word for grouping functions is aggregate functions, which is what the error message talks about. You can use either term. So one grouping function that we discussed was the count function. It's 2 forms, which is count column name and count star. Let's look at another grouping function, sum, which accepts a column name. And as to what it does, well, let's see it in action. So let's give it a go. So I'm going to use order quantity, but within a sum function. Okay, let's see how we go. Alrighty. So that's a little bit more informative. So we're still grouping by product ID and special offer ID. We've only got 1 row for each of those unique combinations. And that's told us what is the total of quantity within that set. So if we were to simply go down, literally if we were to go to our ungrouped and we were to export that to Excel somehow, and we were to look at all the 709s and 3s, and we were to add up all the order quantities, we would get that total. So that's pretty powerful. So coming back to our grouping rules, we can only select a column in a grouped set if we are grouping by it, i.e. that column is physically listed in the group by clause, or that column is within a grouping function, otherwise known as an aggregate function. Now there are a lot of grouping functions at your disposal. I'm going to show you the ones that I've used most commonly in the course of my work. There's average, which gets you the average, and min and max. So let's have a quick go at those functions. So I'm just going to use those functions in my select clause here. Okay, so we've got some examples of those 3. And there you go. So within that set, you've got a total quantity of 341. That's all of them added up. The average within that bunch of rows, and we can see there's 120 rows here. We've still got our count function. So within that 120 rows, the average was 2, the least was 1, and the most was 9. All pretty informative stuff. Now, that's all very fine and well just selecting from one table, but of course we can select from multiple tables thanks to the joining ability within SQL. So let's just get hold of the product name related to this product ID, and I'll factor that in here, and I'll also integrate it into the grouped set, and we'll see how we can use some grouping functions with some of the text columns within the product table. So let's join the product table here. Okay, so there's the name of that product. So let's integrate that into our grouped set as well. Okay, now that hasn't really affected the group set very much. I mean, if you were to break that up, you would see more columns. It basically means there's more columns available to us. It hasn't affected the results because we're still grouping by these columns here, and we've still got the same selections in terms of columns and aggregate functions. So what we can do, however, is that we can now use, we now have access to some of the product columns, and we can use those in the same way. We can either group by them or we can use them in aggregate functions. So you know what? Let's say we're interested in some of the product names in here. So let's give that a go. How about that? In terms of lowest, that is the lowest value within that set because it's a min implies sorting, so it's sorting by that text. It's sorting it alphabetically as you do with text. Now what would happen if we tried to apply what is obviously a numeric function like average to what is a text column? Let's see what happens. Well, that doesn't work. And the error is operand data type nvarchar is invalid for AVG operator. That makes common sense. You can't use a text data type with what is essentially a numeric kind of function. Now, I won't say any more about that, but I would recommend that familiarise yourself with these functions so that we know how to use them and what sort of data types are expected by them. Well, you know what? Let me just fix that problem there, and I'll put that back to min. Now, let's say the business requirement is that we're only interested in those order lines where we have offered special offer ID number 1. Well, how do we do that? We do that the same way we do with any other refining down of our data. We add that condition to the where clause. Great, there we go. So what it's done is, literally this is how SQL Server does it, is it will take this part here, it will form the from clause. It will then apply these where conditions to it, and then that set, it applies the grouping to it using that group by clause and the various aggregate functions up here. Now what if we're also only interested in those the data where the minimum quantity is not 1, it's greater than 1. Well, how do we do that? Well, we could try putting it into the where clause, like so. Okay, let's see how that goes. Okay, we've got an error. What is it? An aggregate, that's this guy here, may not appear in the where clause unless it is in a subquery contained in the having where clause or a select list, and the column being aggregated is on the outer. That's a pretty long and convoluted error. What it basically means is this. That is a grouped function. Now, that is applied to a grouped set. Now, remember what I said about the way grouped sets are arrived at? We do a from clause, not grouped, we just do an ordinary from clause. We apply the where clause, and then we group it. So this can only be applied to a grouped set. It can only be applied to, and you know what, I'm just going to get rid of that and put things back the way they were. So that function of minimum quantity, that can only be applied once we've reached that stage. We've taken our ungrouped rows and we've grouped them, because only in a grouped set can we talk about minimums. We can only talk about maximums, that sort of thing. They only apply, and that question can only be answered within a grouped set. It doesn't make sense to try and ask a grouped question of a non-grouped set. So what does that mean in practical terms? How do we apply our condition involving a grouped function? Well, that's because we've got a very special clause that can be applied to grouped sets, and it's called the having clause. So let's revisit the SQL clauses that we've encountered so far. The select, obviously, the from clause, the where clause, the group by that we've just seen now, and the order by clause, and that's the order that they appear in. Select, from, where, group by, with order by at the bottom. Now I'm about to introduce you to another clause, and that is the having clause. Having is literally like a where clause, but it applies to grouped sets. So it applies to the set after it's been grouped, after the select has been done, the from, the where, all that sort of thing, after the where, after the grouping, and then it refines down the data after it's been grouped. And the benefit of that is, in our having clause, we can refer to grouped expressions. So let's see an example of that. Now, as you can probably guess, we can have lots of fun with our having clauses. We can refer to average instead. Basically, any grouped expression is available to us in the having clause, because that's the purpose of the having clause. So you know what? I'm just going to put average down here. Let's see what happens. Okay, great. Averages of 2 and 4 and so on and so forth, as you would expect. Now, let's say that in addition to that, we've got another condition where we're only interested in those where the minimum quantity is greater than 1. Now, because having is literally like, as I said, a where clause for grouped sets, the same syntax applies when we're combining conditions, ands, ors, that sort of thing. So let's just put that in. And there we go. You get the idea. Well, this is all fine and well, but is there an easier way to get at grouped data? Well, yes, there is, and I'm going to show you 2 ways. First off, it is possible to select an aggregate function just by itself without a group by clause. So SQL is smart enough to work out that if there's no other ungrouped columns selected, and what's up here is just groupings, then it's smart enough to work out, well, obviously he wants to group the entire table together, so it has this sort of shorthand way of doing that for you. I could put another aggregate function up there, and that works too. It is possible to put other parts of the query in, like a where clause. But as long as what's up here is just aggregate functions, that we can just have aggregate functions and no group by clause, we just can't put any ordinary selections there. For example, in other words, we can't have a mixture of non-aggregate and aggregate. It's got to be one or the other, and if it's just aggregate, then no need for a group by clause. Well, I'm just going to do a very simple query from sales order detail. Pretty straightforward. Now, what if I want to just have a very quick snapshot of what are the possible values of product ID in that table? Well, this is how we do it. It's this simple. We put a distinct in front. What's the effect? And we've basically it's done exactly that. It's gotten us the distinct values of that column within the table. It's effectively grouped the entire table by product ID and just displayed those values. Absolutely dead simple. This is quite handy. If I'm examining a new table that I'm not familiar with, I want to know what are the possible values in some sort of a foreign key field, for example, I will just simply go select, distinct, that column, and there's my values. Now we're perfectly free to add more columns to our select clause, and thanks to distinct, it'll group by those as well automatically. So let's see an example. There you go. So simply by using distinct and the 2 columns, I've grouped by those 2 columns, and I can see the distinct combinations of those values. Well, let's recap everything we've learned, and it's been fairly considerable. We learned about grouping, the principles of grouping, the group by clause, and the aggregate functions, where we can collapse rows and then get it summed up aggregated data within those rows. We learned about the rules about selecting columns in grouped sets. We learned about the having clause, which is a where clause, but it's applied to grouped sets. And in this next lesson, we'll look at an efficient way of getting subtotals and grand totals within a grouped set that's using the rollup command.